everyone, and welcome once again to a Xylem special activity only for you. And also this is being live streamed for our colleagues at Xylem as well. So welcome to all of you as well. So today we will spend an hour down in the Research and Development Lab in the Stockholm office. And I'm so happy to be able to share this with you and to show you the lab. This is where you would have been spending half a day if this had been a regular Stockholm Junior Water Prize week. So especially happy that we are able to share this with you. So as you can see here, we are visiting Sweden today, Argentina tomorrow, so don't miss that. It's at 5 p.m. Central European time. Last year, we also we had a visit to our headquarters in the USA. We went to our factory in Italy, to the Shanghai office in China, and also to India, to our tech centers there. So those sessions are available for you to on demand. So they are available on our YouTube channel if you want to check them out as well. Today, as I said, we are in Sweden, just outside of Stockholm, where we have a site of about 380 employees. About 150 of them work in the research and development team, and the Research and Development Center is part of that group. So this office opened in 2004, but Xylem has been in Sweden since 1901, actually. So we are celebrating 120 years in Sweden this year. So in addition to the research and development team, which makes up a big part of this office, we have functions as product marketing, product management, IT, HR, and also the Swedish sales company has its headquarters here. And we also have a service and rental branch close to the lab that you will also visit during the tour. Unfortunately, you will not be able to check out our virtual reality facilities. We usually have a really, nice Fruit Ninja tournament in there when you come and visit. And then, of course, the gem of this site, which is the product testing lab. So with that, I would like to hand over and introduce Hayati. You all met him at the Toast yesterday, and also at some of you met him at the Theme Talk Monday. So Hayati is Senior Vice President and President of Water Infrastructure globally, and also the European Commercial Team. So Hayati, while I walk down to the lab, please, introduce the visit and say a few words to the students.
Thank you very much, Anna. And as you are walking down the stairs, please be safe. Okay.
I will.
Very warm welcome to all of our winners. 44 participants from 32 countries. You are all amazing young innovators. What is as important, which I've learned, is that half of our winners are young girls. So kudos to you and to your interest and passion in science and water. A very warm welcome to our facilities in Stockholm. As Anna mentioned, we have over 300 bright minds in one of our key brains in the company, as one of our key centers for research and development. And those minds wake up every day, and they are consumed in finding solutions to one of the, or more than one of the pressing water issues that we face every day. So I'm hugely encouraged by your energy, your passion, your interest in water. We need your creativity and ideas, and you're gonna see the facilities and the opportunities that are available in one of our sites today in Stockholm. And we are here to work with you, share with you our capabilities. And in future, when you need help, don't hesitate to call us and see how we can help you. So I wish you all a wonderful tour, a productive tour with Anna and Jan. And don't hesitate to put your questions in chat and Q&A for what you're going to see, about what you're going to see in the tour. So with that, Anna, if you're ready, over to you. Or Ellen, if you have any questions in the chat for me, I'm very happy to take them now.
All right, thank you so much, Hayati. Hayati, actually, I have a quick question for you because, as you know, this happened in my home country, Luxembourg, as well. We had many floods across Europe, but across many other regions as well. Can you maybe tell the students here, how does Xylem offer disaster assistance, like in the recent floods across the globe?
Sure. Ellen, with the climate change, extreme weather events are becoming, unfortunately, a part of our lives. Droughts, floods, as we've seen both at the same time in different parts of the world this year in an extreme case, and particularly flood that you're referring to in Central Europe. As a company in Xylem, we pride ourselves sitting right at the intersection of creating both social value in the communities that we engage and we work, and also economical value. So that's what 16,000 Xylem employees are excited about coming to work every day. So I am. So we have a global disaster response team that's 24/7, waiting for calls from whichever part of the world. And as the communities need immediate assistance with equipment, with personnel, with consulting in terms of solving problems immediately as they occur. So we channel our resources to those local communities in any form that they need, with a very quick response, as we did in Germany, in Luxembourg, over the years in Thailand, in other countries. So I would encourage our innovators to be part of it, get engaged with this, because unfortunately, those events, extreme weather events, are with us for time to stay. So it's incumbent on all of us to channel our resources and help our communities to deal with some of these critical issues that they face.
Great. Thank you so much, Hayati. And I see the team in the lab is ready. So let me move to them. We'll get back to Q&A later.
Sure. Enjoy your tour.
Hi, and welcome everyone. I made it safely down to the lab. I'm very happy about that. And I'm even more happy to introduce your guys of today. So with me, I have Jan Becke, who is lab manager, and then Jonas Ramfeldt, who is head of R&D. So make sure that all the complicated technical research questions you ask, make sure that Jonas sort of sweats a bit, stretches a bit, and then all the fun stuff you ask Jan. So with that, the floor is yours.
Yeah, start here with our 3D printer. Of course, we have a 3D printer. We have used this technology for many years. Here we have polycarbonate material. We're making prototypes, different types. Here, for example, we have a hydraulic unit for a pump. We also have much larger 3D printer in the factory. So when we're satisfied here, the 3D printer in the factory prints out a mold that you can make cast iron, so we can get a real product. But we start here. So it was really, really fast for us making our prototypes. And it's really fun to also using it in education, for example, learning. We are a center of excellence, so then you really need to be able to teach out to people. Okay, next, treatment. This department is working with treatment in sewage treatment plant. They are working with aeration or mixing in sewage treatment. For example, in sewage treatment, you're using a lot of air. A treatment plant can take about 60% of the energy can go to aeration. So there you have something to think about to make it better. A good aeration system has about 2 to 2.5% efficiency. So we really, really try to make that better. But so to say, this tank is empty now because we have bought a PIV laser particle velocimetry laser. Then we can't have the tank standing here. The more cost the laser would be dangerous to the eyes. So you have to wear proper PPE and you have to put the tank in a closed room. Actually, the laser will be connected to the door. So if someone opened the door to the room, it will be shut off. So that's why we're moving it. So we're taking it apart now. That's why it's no water in it. So here we have a 3D printed model of a so-called mixer. Mixers are used in water treatment to keep water in suspension and not particle ended up down in the tank. So this is a 3D printed model. And here you have the full scale blade, real product. Mixers are often used 24/7 because you can't stop them. Then you have sedimentation right away. So they have to go using a lot of energy. Of course, we're working with it. And it's also how you position the mixers in the tank. So here we're doing model testing. And then we have some calculation program that we really can make it work as best for our customers. But this is really applied science, actually. And everything we do here, as I said, try to save energy and sustain it for a long time. Next, our EMC bunker, electromagnetic compatibility. It's a really confined area. You definitely don't get any connection with your telephone in here. Inside here, we are testing electromagnetic compatibility. And this is only pre-compliance testing. When it's finished, we move to a second place, much larger one, like a really like a sports arena. But if you go in that room, it's an enormous room. It's covered with these pyramids, you can see there. And there's an enormous door closed. There's a bit, you don't like to be there because it's completely quiet in that room. You can hear your heartbeat. Some people say they can hear the blood in the veins, but you're not used to it. So I don't like being there. It's not dangerous, but just strange. Oh, heavy door. Okay, next thing we're going down is to the monitoring and control. But actually you see here is the control unit in the EMC bunker. They're doing some measurements. I don't know what they're doing now. Maybe some of you know it better than I. Okay, monitoring and control. Down here, we are working with remote testing. We have control system that we are working with remote. So they're actually sitting a couple of floors up here in the house or working from home and working with them. And actually, we really don't exactly know what they're doing now. Testing of level regulators. When you say a lab, you often think about something like this. It's a level switch, and water comes up. So pump starts, then it goes back again. But this one really need to work for a very, very, very long time. They should always work, because this is the last line of defense. If the water goes up, the pump must start. We're working with sewage mortar, and when sewage mortar floods, well, that's not nice. So they just tested and tested and tested and tested. And they are also made for different type of liquids and everything. And it's a little micro switch here inside. Simple product, but extremely important with the quality. Next up would be the application laboratory. Here is the control room for the application laboratory. Here we are working with the control systems for our products in real applications. This is real pump stations that are put into this lab. Normally, this one are dug down in the ground. And when you empty pump station, you need to have this when it's dug down in the ground, because if you have empty pump station, if you have water in the ground, they can come up. I actually seen when we tested it, and that is, yeah, it looks awesome. So we have pumps in there, it pumps up to that tank, goes back, and here they're working with the control system. Here, in this tank, we have real geodetic pressure, as we call it. And the thing is to put in disturbances into this system to try to make them do something wrong. So that's what we are doing here. You run, if everything works well, then you put in some sort of disturbance. Maybe lock the inlet of a pump, like it was a clogging or something, and see what's happening. Another pump should take over, or whatever. Make some fault in some level switch or whatever. It should work anyway. So that's what we are doing here. Another thing that I really love with this laboratory is that we almost always have students here doing the master thesis. They come from all over the world. And when you're with a student for like 6 months, you start to learn to know them. That's really, really nice to get to know people from all over the world. So I think if you're interested in master thesis at Xylem Lab, you contact Xylem H&R. Next up is our new climate chamber. Here, inside here, it's now -20 degrees Celsius. We have a control unit being tested inside here. We have 0 humidity, but we can control the humidity inside here. But if we would have -20 and a lot of water in the air, that would be like ice in here now. We're testing our products through -40 up to about +110. They should work. -40, Sweden is a cold country. Of course, we can get -40. And if the control system is sitting up, it will reach -40. It should work anyway. This one can go down to -90 if you want to, but we're using it for our bias testing down to -40. Oh, finally, you get to see a pump. Most of our products are submersible. It's our whole idea. So, I have a motor, a hydraulic unit. Water comes in there, goes out here. Simple. Rotates. It's submerged. So this sealing system is very, very important. And also another thing I really love with this type of product, this one ain't using any oil at all. You're just using water for lubrication. Because if the pump breaks down in the sewage system, you don't want to get any oil out of it. And if we use oil, then we have oil that are approved as food. And as the thing when you work in a lab, you have to be curious. It tastes like a candle. Definitely one thing working in the lab environment. Be curious. Curiosity is really, really cute. You can find the solution everywhere. Okay, but now we're going to go into the seals laboratory. Rotate. There. So we have a seal mounted there. The sealing system is really fantastic. You have one stationary, this is metal, silicon carbide, and one rotating. The surfaces are so flat that they are sealed off. This should work at least 10 years. Enormous amount of hour running, and surprisingly, it works. You can find these type of seals everywhere. In a washing machine, for example, but then it's probably carbon seals. But this is much more demanding application. Then we need silicon carbide. The seals are pre-mounted like this. So everything at once made from the beginning. But we're going to go into the lab now. Okay, as I said, the surfaces has to be perfectly flat.
Hello, there's a question here from someone. Can I maybe ask it?
Yes?
So the question comes from Annabelle. Annabelle is based in Australia, and she's asking, are these all systems and devices implemented, or are they being tested?
Oh, most of the things you have seen today are being implemented. The newest development you won't see here today. They we have, it's still a lab. It's still company secret. So newest things we don't show actually. But all the things I show you today are implemented. Yes.
Great. Thank you, Jan. Great question, Annabelle. Thank you.
Okay. So the seal has to be perfectly flat. And I must say, I do like simple solutions. If someone comes down with a very advanced solutions, I offer, can we make it a bit more simple? So how to check that its seal is flat? Well, this is a huge industry and everyone using the same type of method. Sodium lamp. I wonder, maybe you can see it there. They have a seal, they have a very flat glass. And if you put it on, I don't know if you can see it, but you get a pattern. And the pattern, 3 lines are 1,000 of a millimeter. And we accept 3 lines error. This is a really, really bad seal. Here we have a good seal. A very quick and easy solution with good quality. And if you don't get any lines at all, then it's extremely bad seal.
Quite honest.
Lamp. Yeah. Okay, but this lamp actually, we built it ourselves like 40 years ago, and then we invested in a new one, but we thought the old one was actually better. So we took it back again. So,
all right, there's one question here.
Yes.
So there's a great question from Eleni. She's from Cyprus. First of all, she's making a compliment saying it's a very interesting tour. You're a great guide. So you create the prototype in-house in small scale, test it, and then proceed to large-scale manufacture. Is that correct?
Yes, but first we go out on field testing. We have like 100 prototypes out in field testing all over the world, but mostly in Sweden, because when you run in the field testing, if it breaks down, we have to drop everything and go there and fix it. So you're out on the customer, but we have special trusted customer and customers that are very interested in saving energy. Because our product should be, all new product should use less energy. So if you have a customer that are interested, I want to save energy, okay, we can use it. But it's a prototype, it can break down. So, and then they call us and then we just run to it. And we've also put separate control system to see what's happening. Okay?
Thank you, Jan.
Next is materials. Materials laboratory. Materials are very, very interesting because they are a key factor for quality and cost, and also have ethical problems. We will never buy conflict minerals. I've seen actually the documents from the management. We should never, ever buy conflict minerals. Here, for example, we have some test samples of paint. This is cast iron. Then I put down in a small tank with water and salt and some air. This one has succeeded very well. And this one's not. So most of this one has not succeeded, but this one looks okay. Here we also have propeller. We have been testing a new type of coating to make it more durable against wear. Now we're looking at that. To use coating is a way to make it a little cheaper and not use so much of this high performance material, as we call it. So this is just stainless steel that has been coated. So let's go further. Here we have the prototype workshop. Here we are making prototypes. Most prototypes are made in the factories, but we are doing some extra works to them. We also remake them, repair them. So it's very, very good to have our own workshop inside the house, and it really boosts the creativity. Because if you have an idea, you would like to do something just now with it. So I really enjoy people here that can handle these types of machines, because then they have closer from idea to reality. Next up is beer testing. We always try to save energy, so the lamps are shut down when we're not in the room. Then you turn them on. Then we're only using LED lighting inside this lamp. And above this lamp, we have 950 square meters of solar cells. Your energy saving are some private interest for me. Okay. Beer testing, accelerated beer testing. Inside here, we are very proud to completely be able to destroy a pump in 100 hours. Normal test in here is 100 hours, so we start on Monday morning, then it's finished at Friday lunch. And we're using 20% of solid, normally different types of sand, and some rubble. Makes a terrible noise. And here is what you can do. You have to be a little careful, you could get sharp edges after a test. So here we have seen somewhere. So before a test, they are performance tested. Run these tests, wear testing, and then performance test again. And if it's possible, retrim it and see if you can regain the performance. This particular impeller has been around for 200 hours. After 100 hours, we changed the sand because the sand was worn out. This is the drainage pump. Drainage pumps are used in mines and construction sites. A lot of sand and there. So, but after this 200 hours and retrimming, it was actually better than new. But you see the surface area, so nice. But they are getting fairly thin after these 200 hours, so maybe not 100 hours anymore. There's also another impeller that we overdid it. So this is great. And sometimes, yeah, it wins over the equipment. And wear testing is hard for the products, for the equipment, and for the personnel, because sometimes it breaks down and then they have to clean the lab. It's just the nature of the test. That's why we always close this lab during the test, so no entrance. Next up, motor testing. We are developing our own motors, high performance motors for a special application. Here we have a prototype, an old prototype for a permanent magnet rotor. Here we have the rear rotor. It's a very strong magnet. As you can see. Now we have launched a new series of motors, new pumps. This is so-called a permanent magnet, single tube permanent magnet motor. You can find it on places where you like to have high performance and to be a bit smaller. I have an electric car myself. It has this type of motor. So it's the first pump in the world, commercial pump in the world with this type of motor. It's a really high efficiency. Can reach up to IE5 in certain regions, but IE4, that's a European classification. We are alone on that. Here we have the stator, very compact. The size of this motor is half against a standard asynchronous motor. But this is a synchronous motor. Here we have the stator plates. I don't have any proof for this one, but this is the stator plates. And I might think where Tesla got the logo from. I don't have any proof, but maybe. This motor are connected to a frequency drive that can adjust the RPM and put some intelligence in it. And here we have the product. Pump housing, motor, and frequency drive. Mounted in one package. We are fast on that one in the industry. Everything developed indoors. We own the motor, we own the frequency drive, we own the logic, everything indoors. Yes, we have a lot of test benches for motors. Here, the typical test bench. We have a test object, a torque meter, then we have a generator. We put a load on the generator and brakes the test object to see the performance. We go all the way until it stops. Then you can get out everything you want from that motor. We have 5 of these test bricks, and we can go up to 500 kilowatts. Go from 20 to 67 hertz with perfect sinus wave and 0 to 6,600 volts. Half of the cost of building this laboratory of the power system, and I know because I was the project manager for building this lab. We're binding in 25,000 volts to this lab and have 5 huge transformators. Next up, hydraulics. When we're working with sewage water and pump, you can find anything down in sewage water, absolutely anything. And actually, so I saw from Mexico a picture where there were a donkey inside the pump. Horrible, but yes, big pump. I found teeth ones, not real teeth, but someone had the extra teeth, and in some way they ended up in the pump. So you can have clogging problems. This is a pump impeller. Something gets in. We have had the pattern for this one. Gets stuck. Then, when it rotates, it mechanically cleans itself. This impeller has been developed here. We have recently lost the patent because we had it more than 20 years. It has been developed in here. But the small pump rig we're going to look at now is one of the absolutely most important in this laboratory. Because the clog pump uses enormous amount of energy. But the lost patent of this one, but we have this. The adaptive. If something big comes in here, it squeezes itself, it never jumps, and it goes further. This is interesting because they have a current peak when something passes. This one reduces that current peak for half. That can be directly translated into the lobes of the bearings and everything. So it's really sustained performance. No clogging, no load on the bearing. But we're going to test this now. A quick test. This testing there. Have a pump mounted, it's a very small pump. That one, only 1.5 kilowatts. The new one I showed you at the motor side, this is an 8 kilowatt pump. This one.
Before we do the test, there was a question.
What question?
Yes.
Jan, before you do the test, and I can't wait to see that. This is always the greatest part of the tour. There's a question from Ali. He's from Turkey. First of all, he's saying the tour is very fun. Thank you to you, Jan. He has a question. Do you design the motors yourself, or do you produce another design?
We design all our motors ourselves. They are designed indoors. And this new revolutionary motor is designed in here.
And you can also
Thank you, Jan.
you also produce and manufacture most of the motors as well.
Yes.
So it's designed and built internally.
Yeah. Okay, we will start here now.
Great. Thank you, Jonas.
So here we have the inlet of the pump. The pump is mounted here. Now it's running, but you really can't see it. But I put on a strong stroboscope light, very strong. Close your eyes. It's about 1450 RPM now. But I'm going to test these ones now. Without them in testing because they are very hard, because they have high surface friction. Not so common in sewage system, but very common in Swedish kitchen. So we put the three. No problem. Five. Normally, a pump in this size gets into serious trouble when you put in 5 of these. We should pass through here. It's a similar impeller mounted in this tank now. You can almost hear the impeller jumps. manufacturer, this one, has actually visited us twice here. But we used about 20,000 just to develop this impeller. And I get the Christmas card from them. So I said 5 was difficult. Of course, you have to move to 7. No problem. Works perfect. And if the customer would find something big like that in a product, they will properly say it's okay. And it shouldn't be able to do too much, because then it's better to plug the pump than plug the pipe system. Actually, much better. We need to have a limit for how much it takes through the pump. Yes. When we're testing here, this is a performance curve for a pump. Head and flow, use of power, and efficiency. This is the curve for the pump we were testing now. And we were running at 20 liters per second, best efficiency. I've seen a lot of films in the YouTube where they are running outside here. That is cheating, but you can get anything through that. Okay, next up, the heart of this laboratory. The PTR test rig, that means performance test rig. We were looking on the performance of the whole product. There are 2 tanks. In this tank, we can test flow up to 2,000 liters per second, and up to 500 meters in pressure for 50 bars, 20 to 67 hertz with perfect sinus wave, 0 to 6,600 volts and 1,000 amps. But here we're looking on the. This is a huge instrument with a huge pipe system down underneath there. And it's all constantly calibrated. We always have to know exactly what we are measuring here. It's actually a drainage pump being run in the tank just now. Drainage pump used in mines and construction. I'm going to introduce you something new that has recently been launched, and it's very revolutionary. I mentioned the smart, intelligent sewage pump. Well, now I have put the same technology in the drainage pump. A completely different problem. This is the world's first smart drainage pump. We call it the Bibo Alpha. And it reduces the use of power enormously and uses the wear enormously. If you see a construction site, you have a hole, you have some water, you put the pump there, pump gets the water away, then it starts snoring. It's standing there and snores, using energy, and hardly don't do anything. This has some smart intelligence that will reduce the RPM on the pump to save the energy and save the pump. Really revolutionary. I think it scares our competitors. And that makes me proud. Next up, the cable endurance testing. We also develop our own cables. We are not producing them, but they are produced according to our own specifications. But we're producing like 140,000, 150,000 pounds a year. Most of them are delivered with a black rubber cable. So we are using a lot of black rubber cables. So here we have the cable endurance testing. And we call it the cable salsa. We are dancing here. The cable that is mounted in the pump station are bended like this constantly, not as much as you see here. The cables never break, never break. Then you have to have something mechanically, but leads can break inside the cable, especially these small control leads that we nowadays need for our control pump. All products are getting smarter and smarter. These can break. These can break. So here is where they're tested. And you see they're tested with the support structure and without. You see the rubber down there. And it makes a huge difference by using the rubber. Yes, it does. And I have one last thing in this lab. It's so easy to be in a lab and get away from reality. Well, in this lab, we have something unique. The reality is there. Inside here is the service
There is another
station
question.
in Stockholm.
Yes, there was one question again from Cyprus. We would be interested in any experience you may have in the construction and maintenance of glass-aligned steel water tanks.
Okay. I really need to think about that one.
All right, we'll get back to that towards the end. I'll ask the question again.
Yeah. Okay. We have the real service station here. This is the service station for the Stockholm region. And if they have some trouble, we definitely get to know about it. We can also expose them to our new ID, and they can say, "Are you nuts?" or "Great." Or they can help us test the prototypes. And never underestimate take a coffee with the service guys. So it's really, really, the whole idea here is to have this in the same. So I think it was the last. So we will go continue to the entrance, and then it would be the Q&A, and hopefully enjoy the tour.
Thank you for joining us back here, Hayati. So one of the questions I was thinking about when you were at the clock test rig, this is a question for Jan. Jan, what is the biggest thing that you have pumped through the clock test rig?
Sheets. Sheets you have in the bed. Yes. And that's why if you use a pump on extreme right curves and use a special type of impeller, you can pump almost anything, but it's cheating. It's not for it.
Jan, we couldn't hear your answer. What was the biggest thing you pumped again?
Yes, the biggest thing is as a sheet from a bed. It's the
Bed
biggest
sheet.
A bed
Okay.
sheet.
Yes, yes, and towels.
Towels.
Also. Bathing towels.
Mm-hmm. Great, great. It's really interesting. I love that clock test rig. So just
also,
checking in for...
If you got a cutting pump,
Go ahead,
the
yeah.
cut up things, if you got a pump that cuts up the stuff, they're using more energy and they are less energy efficient, but then you can put in anything. I put in a working clothes, like an overall ones, and it just...
Great. So I'm just coming back to Eleni's question, and I know, Jan, you wanted to think about it, but maybe also if anyone else wants to answer that, or if we want to get back to Eleni by email, that's fine as well. So she was interested if there was any experience that we have in the construction and maintenance of glass-lined steel water tanks. Is maybe anyone who has that answer? Otherwise, we'll get back to Eleni by email.
We need to talk to the materials. I have some experience of glass fiber tanks, but not glass and steel. So that's material, guys. So can we get it on an email? We can arrange it with the material.
Excellent. So I'll make sure to copy the question and send Jan an email copying Eleni. Then you guys can connect on email through that. Maybe a question for Jonas. Jonas, what kind of background do you need to work in the Research and Development Center of Sundbyberg, or maybe any other R&D center we have across the globe?
Yes, that's a good question, and that's what makes me excited to go to work every day, because we require a very broad spectrum of backgrounds and specialists. As Jan has so nicely presented today, I mean, we need everything from obviously mechanical engineers, people doing calculations, stress calculations, material experts, chemists, and also now with the digital journey we're on, we are adding more and more electronic engineers, software engineers, machine learning, AI. So I mean, it's everything. It's really interesting to go to work every day and have people engaged, and it's like Jan is making me really happy to be here.
Great.
Ellen, can I add on to that
yeah.
one?
Yes, of course.
Maybe broaden the question. You know, we have multiple other type of jobs in Xylem. We have 16,000 colleagues in different functions and roles. And if I need to answer that question in a broader term, if you are curious about the world and solving the problems in the world, and if you care, come and join us, irrespective of your background and what you study.
That's a great addition, Hayati. Thank you so much. And so maybe there is any question. I mean, there's a lot of you on this call today that are studying in this field. Any other questions from anyone as participants? Okay, I'll have another question for Hayati. Maybe to close this call, because I see we're at the hour as well. Hayati, what are innovations that you are seeing that you are most excited about in terms of making the sector more sustainable?
It's a great question, Ellen. Look, I mean, innovations that we drive and our industry drives focus on a couple of key areas. One, to address water scarcity that over 1 billion people face on Earth, driving water reuse and recycle is one of the key areas. So we invest heavily in equipment, technology, digital solutions to enable communities to reuse water. Okay, that's number one. Number two, to contribute to the challenge we have with climate change and CO2 emissions, all of our products and services are designed, a couple of things in mind, but one is less materials, more recyclable materials, and more energy efficient solutions. So energy efficiency, reuse, and the third one that connects all across is the use of digital and artificial intelligence that we use more and more to optimize the operations of our clients, public utilities, water companies. And that is the next big thing in delivering optimum solutions by use of digital technology. So those are the three areas, Alan, I say, where the trend is, what drives our thousands of researchers every day and bringing them to the work to solve these problems.
Great. Thank you, Hayati. Let me see, I believe there's one more question. So this is from Ali. What kind of works do software engineers do at Xylem?
Okay, I can take that.
Go ahead, Jonas.
Yeah. So what kind of work? I mean, we do software in all the different, you can say, architecture layers of the technical solutions we have. So the pumps, some of the pumps, the smart pumps that John showed, We do intelligent algorithms, which is of course implemented in software in that. So that's really embedded software close to the hardware. Then we do control systems on top, also shown by Jan in the EMC chamber. That's also embedded software doing application for smart process controls. And then we do service tools on Windows, and of course, smartphone applications. And also lately, as Hayati mentioned, when we're building digital solutions that to bring everything together, we're also developing cloud applications, for instance, on Amazon. So we have I would say, almost all kinds of software discipline under our roof. It's also very exciting because we can make a very tight integrated solution that fits and plays well together.
Great, thank you, Jonas, for that. So I have just promoted all our participants here to be with us on this panel. And if you want, please go on video, because as you're used to this now, right, we would really love to take a picture of this. And if I can ask the team who's in the Sundbyberg lab to just go together. And Annabelle, could you go on video? Great. Ali, Andrew, if you don't mind. Thank you, Eleni. All right, so if everybody could wave in the camera, you're used to this now, right? Then I'll just take a picture so we have everyone. This is just such a great experience. I'll let you know when we're done. Okay. All right. Thank you, everyone. This was a great session. Thank you to the team in Sweden in the lab. A big applause from everyone. This was really a great session. Such a great tour. Jan, thank you for talking us through that. Have a great rest of your day, everyone. And thank you for joining us.
Thank you, everyone.
Bye-bye.
Bye-bye.